Hello, learners. Welcome back to Wizartist. Today, we are going to be studying Class 8 Physics, Chapter number 12, Some Natural Phenomenon. This is the first part for this chapter. In this chapter, we are going to study about natural phenomena. What exactly do these words mean? Natural means something that occurs naturally without human interference. That means that human beings have no influence over these events or these things. Phenomenon means any event in nature or society, mostly something that is unexplained. That is, the reason why that happens is not yet known. In this chapter, we will be learning two such natural phenomena. The first one is lightning, which we will be covering in this video. And the second one is earthquake, which we will be discussing in the next one. Let's start off with the basic concept of charges, which we will require to know as a prerequisite to understand lightning. The ancient Greeks knew as early as 600 BC about this activity that is a base for the study of charges. Let's have a look at this activity. Let's take amber and rub it with fur. Amber is a kind of resin, fossilized tree resin. Resin or resin means a sticky substance or gooey substance that is found underneath or below the bark of some trees. When the sticky substance of resin is buried under the earth for a lot of years, it fossilizes and becomes amber. After this amber is rubbed, it can attract light objects like hair, as you can see over here. Let's have a look at another activity that gives similar results. Let's take a pen refill and a polythene and then rub them against each other. We can say that they get charged by rubbing. This means that these objects are no longer neutral. That is, they now have some electric property from charges that come up on the surface of these objects. Charges can be considered as a property of subatomic, that is, particles present in atoms, that gives them electric properties. These charges interact with one another. That means they repel or attract each other based on what type they are. Now, if you take a piece of paper, it gets attracted towards the pen refill. This is exactly due to the phenomenon of the pen refill getting charged. Here is a table showing objects that when rubbed by some other material attract pieces of paper or not. And if they do, does that mean they get charged or not? So first we have a refill, just like we saw, and a polythene. Instead of a polythene, we can also use a woolen cloth. Once you rub the refill with a polythene or woolen cloth, it does attract a piece of paper, and therefore you can say that it also gets charged. Similar thing will happen when you rub balloon with polythene, woolen cloth, or dry hair. It's very important for this material to be dry and insulating. It also attracts pieces of paper, hence it gets charged. If you rub eraser with wool, then again, it attracts piece of paper and therefore it does get charged. It's important for this wool to be dry. But here's an exception. If you take a steel spoon and then rub it with a polythene or woolen cloth, you will notice that it does not attract pieces of paper. It does not get charged. Why does this happen? It's mainly because steel spoon is a conducting material. And if there will be charges on it, because it is a conducting material, the charges will get transferred and not remain static. Now, there are a few concepts that you might not have understood as I just said this, like what is static charge and what is flow of the charges. We will be understanding this when we go on to the conductivity or the transfer of charges ahead. So, from these activities, we have a conclusion. We can say that the charges can be acquired by rubbing it against certain materials, which must be dry, non conducting, that is, insulators. Such charges are static, just like I said. Static means not moving or in one place. The charges that do not move by themselves, that is, when there is no external force, they will stay in the same position, called static charges. But It's not that all charges will stay in one place. If there is some external movement or if there are conductors, these charges will move, can move. Such moving charges are considered constituents of an electric current. If there is a charge that is moving, it means that it is forming an electrical current that flows through a conductor. So static charges do not move by themselves, they are in one place. And if the charges are moving, it means that they are forming electrical current. We have already studied about electricity and electrical current in earlier classes. So what forms this electric current is the charges that are moving. So we have rubbed this refill against the polythene and it has some charges that is not moving. This means this charge is static. But on the other hand, if we have a look at these other set of charges, they are moving ahead. This means they are present in a current or flow of electricity. So over here, basically this lightning shows charges. Okay, we've just used it as a symbol. So over here, we have it not moving. It's in the same position, so we can say that it is static. But as we just saw, if they're moving in whatever direction, it means there is a current, there is a flow of electricity. So basically we can say that the movement of charges is the flow of electricity. And if charges are static or stay in one position, they have some other properties, which we will eventually study. Now, what happens when different or similar kind of charges interact? Interact means when they are in the proximity or are close to one another, what are the observations that we can see? Let's conduct a few activities and understand. Let's take two balloons and rub each of them with a woolen cloth. Now, one must remember that this woolen cloth should be dry. After you've done this, we can say that they get charged by rubbing. And you can notice after a while that they repel each other. That means they move away from each other. But now instead, if you take a charged balloon and a charged refill that again are charged by rubbing against a woolen cloth or polythene, you can notice that these two objects will move towards each other. That is, they will attract each other, which is the complete opposite of what happened last time. That is, with balloon and balloon. Balloon and balloon repelled each other, but balloon and refill have attracted each other. This kind of gives a conclusion that there can be two types of charges, positive and negative. We have named one type of charge as positive and the other as negative. In this video, I'll be representing positive charges with this positive plus red circle and negative with this minus green symbol, as you can see over here. These symbols will help us get a proper visualization about their interactions. If we have a look at unlike charges, that is, one positive and the other negative, or vice versa, you can notice that these charges attract each other. That is, they move towards each other. Therefore, positive and negative, that is opposite, unlike, or not similar charges, are attracting each other. But now if we take similar charges, that is positive, positive together, or negative, negative together, which we call as like charges, you will notice that they move away from each other. That is, they repel each other. Therefore, we could say that if there is a similar kind of charge that is both positive or both negative, they will move away from each other. That is, they will repel each other. Similar thing is noticed with a magnet, though, isn't it? We can draw many similarities between their interactions between charges and interaction between the poles of magnet. Like poles of magnet, that is north-north or south-south, repel each other, while opposite, that is unlike poles, north-south or south-north of a magnet attract each other. Similar thing is seen here, isn't it? Electrical charge can also be transferred from a charged body or object to another object through a metal conductor or basically any conducting material. Here we have a charged refill. These lightning symbols again indicate that it is charged. Let us take any conducting material, which is usually a metal. You will notice that the charges of the refill flow through the conducting material and will reach to any object placed at the end of the conductor or simply go into air. Therefore, we can say that electrical charge can be transferred from a charged object to another through a metal conductor. Now, there is an application of transfer of charges, which we can understand with this activity. Let us create an apparatus like this, where we have a charged refill, a transparent jar, which has two aluminum foil pieces suspended through a wire. This apparatus is called an electroscope. When we touch the charged refill on the metal wire, the charges from the refill get transferred to the aluminum foil. So this refill has some charges. And when you touch it with a metal wire, because it is a conductor, these charges get transferred and they move downwards towards the aluminum foil. So suppose there is a wire, this wire, and it has the charges from the refill. And then here we have two aluminum foils. Right. So initially, these aluminum foils are together with each other. Right. And then you get charges. That means this one also gets charged and this one also gets charged. Both of them have similar kind of charges because both of them are aluminum, same material. And because they have similar charge, we can say that they get like charges and therefore they repel each other. Now, because they have like charges, they will repel each other. And therefore, you can notice that their original position, which was something like this, gets converted into something like an inverted V. That is, they repel each other. This electroscope helps us understand the intensity of the charge of any material that we are touching. The same has been summarized over here. Charge from refill transferred to the aluminum foil gives them like charges and hence they repel each other. Now, if you touch the aluminum foil, you can observe something else. Now, what happens basically is that the charges on the foil gets transferred to your body because your body is also a conductor. And through this conductor, that is your body, it travels to the earth. When this happens, that is, when the charge moves towards the earth through your body, the aluminum foils collapse because they get uncharged. They lose their charge, and because they lose their charge, they don't have any force that is keeping them repelled. Therefore, they collapse. Let's just have another look. Just observe over here. When you touch, they collapse. That is, they were like this because of the repelling charge. The repelling force due to the charges. Now, because there are no charges, they return to their original position, which is something like this together. This process of transferring charge to the earth through any medium, which is our body in this case, is called earthing. We will understand the importance of earthing as a precaution method ahead. Now let's come on to our main topic, that is lightning. We will understand what causes lightning, how can we protect ourselves from this phenomenon, etc. Whenever there is a thunderstorm, there are a lot of vigorous movements going on in the environment. What are these? The first one is the falling of raindrops, up to down, downward movements of the raindrops. And the second one is the upward movements of air currents. So you can see that there are a lot of vigorous movements. There is so much chaos right now. These vigorous movements causes a separation of charges due to some unknown reason. What does separation of charges mean? It means that initially the charges were positive, then negative here, positive here, negative here, completely randomly. They did not have any particular position. But now, all the positive charges get accumulated or collected on the upper region of the cloud and the ground, while the negative charges are collected on the bottom part of the clouds. Now, theoretically, these charges shouldn't have any effect, right? Because air, which is the medium present here, is a poor conductor. Just see what I said here. Poor conductor. I did not call it an insulator because in extreme conditions it may act as a conductor. Hence, poor conductor is a better term to use. This process of accumulation of charges also poses such an extreme condition which creates this exception. This means that when the magnitude of these charges that are separated becomes very large, very high, even a poor conductor like air cannot resist or stop their flow. Thus, in this case, for this moment, air also becomes a conductor. And because air becomes a conductor, we understand that the negative and the positive charges attract each other and therefore they will meet each other. So, first, maybe from the ground to the bottom part, or even among the clouds, these positive part and this negative part, they will meet each other very suddenly, very quickly, and because they will meet, they produce streaks of bright light and sound, which are understood by us as lightning. And this entire process of these charges getting separated and then meeting each other is called electrical discharge. This electrical discharge, as I explained, can occur between two clouds, that is, like this, between these two, or between the clouds and Earth. Right. So, again, electrical discharge can occur between two or more clouds among themselves, or even between the clouds and the Earth. That's why you must notice that some lightning stay in the clouds, stay in the sky, and you cannot see its effect on the ground. But some lightnings have an effect on the ground. Because they have some effect on ground, we need to be safe from them. Therefore, precaution and safety against lightning is very important. Thunder is an alert to rush to a safer place. So, first thing to do whenever there is thunder, find a safe place. If you're in a house or a building, be assured it is safe. If you're traveling by a car or by bus, you are safe if the windows and doors of the vehicle are shut. So, that is the condition. The windows and doors should be closed for safety. Outdoors, open vehicles like an open car, motorbikes, or tractors are not safe. Being near construction machinery is also not safe. Carrying an umbrella in a thunderstorm is not a good idea at all because we know that these ribs or the frame of the umbrella is made up of metals or any conducting material. And conducting material will attract the lightning and can pose a threat to whoever is using an umbrella. If you're in an open ground, it is best to stay away from tall trees, shelters, and elevated places. It is best to stay away from poles and other metal objects. And do not at all lie on the ground. Instead, if you're in a forest, take shelter under shorter trees. Instead of lying down, squat low on the ground like the given image. Indoor lightning safety. At home, avoid contact with telephone cords, electrical wires, and metal pipes. Also, avoid bathing during thunderstorms to avoid contact with running water. It is safe to use mobile phones. However, it is not wise to call a person who might be receiving your phone through a wired telephone. That is, even though you are using a wireless phone, if the person you are calling who will receive the call is using a wired one, it still may pose a risk. Electrical bulbs are okay to use. Electrical appliances like computer and TVs should be unplugged. Now let's understand about lightning conductors, which uses the concept of transfer of charge and earthing. Lightning conductor is a device that helps protect buildings from effect of lightning. A metallic rod taller than the building is installed in its walls during its construction. So this blue rod is the lightning conductor. One end of the rod is kept out in the air while the other is very deep under the ground, usually attached to a copper sheet underground copper plate or copper sheet that helps with the earthing. When lightning strikes, this rod provides an easy route for the charges to get transferred to the ground without causing any shock or damage to the building. Remember not to touch them during a thunderstorm for obvious reasons. That is, they have charges on them, they attract lightning towards themselves, and if you touch it, it is very sure that you will get a shock. The metal columns, or in Hindi we say sariye, used during construction, electrical wires, and water pipes in the building also protects the building to a certain extent. And that's it for this video. Part 2, that will be the explanation of the second topic, earthquakes, will be out soon and linked in the description. Hope you liked this video and learned something new. If you did, don't forget to like, share, and subscribe. Until next time, bye bye.